show the video a little bit. Go ahead.
Hurricane.
Hurricane, good. Yes.
Fires.
Fires. Yes. Yes. What's something that we feel in the summertime?
Heat waves.
Heat waves, yes. So there's lots of extremes that we can think about in our buildings. This building right now, we're kind of cool, and you know, but when it was really, really cold out there about a week and a half ago, it was really hot in here. Yeah. And so it was something to where the buildings are almost kind of like you have to live in them and make sure that they take care of you from the surroundings as well. So today, we're going to talk about the building through some of the extreme temperatures, extreme weather, extreme everything else, and focus on a couple of some hurricanes and what else we got. So George is going to give us some numbers and see where we are on some of these items right now.
Yeah, I have to write down some notes because there's a lot of stats. But yeah, pretty much you guys covered all of these extreme weather events that we're seeing. This map was just, it's a map from NOAA, and which is a government service, and it's basically they map a lot of like weather and oceanic like patterns and things like that. And so they have this whole map of the U.S. of like $1 billion disasters. So it's not even like every disaster and where they're concentrated. It's like the most expensive of the worst disasters. So yeah, we get a lot of them in Texas and Florida because we get hurricanes and tornadoes and droughts and heat waves. California gets a lot of drought and heat waves and wildfires, and so they're up there as well. Oh yeah, this is a fun graph. So the frequency of billion-dollar disaster events has increased 7 times over the last 40 years. So it's like 7 times worse than it was in the 80s. So just between 1980 and last year, I put some stats on there. 32 billion drought events, 67 tropical cyclones, which includes hurricanes, 203 severe storms, 23 wildfires, 45 floodings, 24 winter storms, and 9 freeze. These are all billion-dollar disasters, so not just like regular freezes and regular hurricanes, the ones that cost more than $1 billion. And I don't know why there's a black box there all of a sudden. But this is just a nice Venn diagram we have at the National Glass Association. Like at least half of it, what glass can do in a building. So as engineers, what we can do is design. So reducing greenhouse gases is great, but what do we do in the meantime? So like we're trying to fight climate change, a lot of us on our own, a lot of us with companies, but in the in-between, we still have to like live places and work places. So what we can do is like design for these extreme weather events.
Are we ready to load it?
I can try.
We need to load it.
Sorry, it's super small.
So this is a video that actually showed Los Angeles. And so I don't know how many of you have actually seen, excuse me, seen the news when this was happening in January. And these are $1 million homes, stars, movie stars, Hollywood, you know, all of these people who put in a lot of money. So they have their affordability to build a home the proper way or the right way and all of that. But 17,000 of them are gone. The buildings, their homes are no longer there. And it's, can you actually rebuild there now? Those are some of the questions that as engineers, architects now need to take a look at. It's like, how do we rebuild, but rebuild properly? But then every once in a while, you'll see a home that survived. Well, what happened to that home? How was that one built differently? What was the reason for that to be different? We had a really, really good presentation. I don't know what's happening. There you go.
Anyway.
You want to take this one?
Yeah, sure. So, like Irma said, like, how do you build around that? So just watching the LA fires, you probably saw there's like a couple of houses that were viral for like being completely standalone, surviving while their neighbors were just completely destroyed. Super sad. But you can see like certain patterns in those houses that did survive that are like the same on every surrounding house. So a lot of these are like very well-known facts. So prevention measures in California, they're pretty well known. So you want mesh roof vents. You don't want open roof vents that siding, super pretty, very blue. So outdoor sprinkler systems, obviously. And then double pane windows or some sort of tempered glass. That glass might still break and keep, but it's going to give you extra time for your house to maybe survive and not catch fire. So yeah, homes ignite in one of three ways. It's either the embers that are flying around, those come from miles away with high winds, and that did happen in LA recently. You can see that from miles away the fires are raging, the embers are getting to the coast and burning houses down. Radiant heat, it just gets so hot, things ignite, or just direct flame contact. So this is an example of a house that survived, that went viral. And you can see that has tempered glass windows. Some of those did break, but it gave the house kind of time to be hot and not just catch flame. It doesn't have any surrounding vegetation, or if it does, it's some low-lying native plants that are going to that can be gone. It has fire-resistant siding, a concrete barrier wall, and a fire-resistant roof. And the shape of the roof is also important. There's no like depth eaves where embers can sit there and start catching fire.
So I like right here, where she's talking about like some of our homes, like even my home, has a little bit of a like an awning there, to where if you actually have, if there's embers flying around and something goes in there, sometimes like there's cobwebs or there's a bird's nest or something like that that's flammable, you can have something like that that then goes into your home. But this roof has nothing like that, so that's where this is one of the reasons why this one's survived.
It's kind of the same thing for these houses. You can see some of their glass survived, confirmed tempered glass. And then, yeah, those flat roofs that they're not catching anything under them, they're not hugging debris. So it just gives those houses some extra time. That one does have wood siding. I think that one's kind of normally, but the rest of it is like pure concrete, pure glass.
And I think on here, because the wood part did not catch fires because of the surroundings. So they did not have a lot of plants. Like she mentioned, it's like whatever's native to that area. So something like, I like hibiscus. Well, hibiscus is not for Texas. It's for a little bit more of the, like the equator type of more humid. So something like that, the plants are not supposed to be there, will become, flammable, and will kind of, just start with that. So having around the actual building itself, having some type of security around that or thought process when you're building a building for flames, and just have that can protect the building as well.
I don't know why. Well, the picture was of a home. I don't know.
Okay, how many of you know AV?
What is my picture?
It's not really
I told you that flash, right?
It's one of those like snappers flash drives.
Oh yeah, it's really fun, but like you said, really useless. That's okay.
So the main thing about buildings, your building that if you live in an apartment, if you live in a home, if you live in like anything, even this building right here, there's insurance. There's insurance in this building. As a property owner, one of the main things is that you have to protect the building. So if by chance your building gets flooded, or a tornado in this area, or hail damage, there's an insurance claim. So one of the California, with all of these fires that just happened, is that insurance companies can't afford to pay out to rebuild what they have. In Florida, with all the hurricanes that have happened before, and continuously happening over and over again, insurance companies cannot pay homeowners out to now go rebuild. So what do? You just lost every single thing that you have in your home, and some of the office buildings, some of the schools, hospitals, things like that are gone, and you cannot rebuild. And so it's becoming more and more of an issue. So we need to now start looking at how we're building in these areas.
Yeah, the quote that I like from Dave Jones is the director of Climate Risk Initiative at UC Berkeley. He says insurers aren't going to be able to rate increase their way out of the climate crisis. So he said that the losses and damages from climate-driven events are going to outrun any insurance rate increases. We just can't keep up. It's not all the insurers' fault. They simply can't keep up with the demand for help. And so one of the things that buildings in general
that a building code, does any of you know what a building code is? Yeah. So pretty much the way to describe a building code is the absolute worst building you can build legally. That's what your building codes are for. It's the minimum bar for everything else. It's the worst building you can possibly build. And so what we've talked about is that you can build above code in cost money. You can build for fire resistance in California in cost money. You can build for a hurricane impact in Florida, or you can build for a tornado here in Texas, but it costs money. But the upfront money that you can put into something like that outweighs what happens when an actual disaster. So one of the things that I do is I work a lot on buildings on standards that then go into a code. And working with insurance companies. So the reasons why people change and why things become better is usually because the government tells us we have to do it. There's a law in place. Or there's an insurance company that says, we're not going to pay out and then until you do this. There's not a lot of other reasons why people pay the upfront costs for things. You know, usually it's not like, you know, somebody has all the money in the world. Like I said, in the California area, these are actors and actresses that have a whole heck of a lot more money than you and I, but at the same time, they lost their homes as well. And so it's when you're building it, to be able to have that upfront cost. And one of the other initiatives that we're working on is that when you buy a house, an existing home from somebody else, have somebody come and check that. Is it up to par with the newest standards, the newest codes? So that way, you now as a brand new homeowner or a building owner now knows that, okay, this is now to this standard. It's not from the 1970s, when they didn't have any type of security or fire ratings or anything like that. It's now up to today's codes.
So another reason we need this is for hurricanes. So hurricanes are, they affect us a lot in Texas. Maybe not as much in DFW, but you'll see it really does. So just in 2024, I pulled out these 5 multi-billion-dollar storms hit the United States, and so the total estimated damage just in these and not the smaller ones is $124.1 billion with a B. And that's like a lot of damage.
Yeah, and some of these are category 1. So a couple of years, was it last year, the Richardson had like a thunderstorm that came through, and it was about category 1 hurricane winds. And so that's why there's so many trees down and all of that. You guys saw that. Some of our homes didn't have damage at all. So our homes are built a certain way. However, trees came down. Our surroundings are not built that way. We're not taking a look at what that means. But that was just category 1. The category 1 there, $7.2 billion. But because of that, it was the tornadoes that also came with a hurricane.
Yeah, so the amount of damage from hurricanes is not just like the storm, the tropical storm, or the cyclone itself. It's like anything that happens after is included. So like the flood damage, the flash flooding that happens often. Like recently in Asheville, North Carolina, you saw that hurricane, what was it, Helene? Yeah, Helene produced all this flooding in like North Carolina and Tennessee and Virginia, and it caused landslides, and people died, and like entire cities were like towns were wiped out. And they didn't even get like hit by the hurricane per se. It hit Florida, but it caused all this like accessory damage. So yeah, obviously not super great for buildings. So it can cause like big winds and rain, cause material and joint failures. There's a diagram down here about glass, obviously. So with this impact-resistant glass, if your windows don't break, another advantage is that your house isn't going to get like lifted off the ground. Your roof isn't going to fall off, which is like a very common hurricane side effect. People's roofs get like literally lifted off their house and then drop, which is like one of the biggest causes of damage to homes.
So in Florida, one of the things, I used to work for a hurricane test laboratory in Florida, and one of the things that they used to say, especially during hurricane times, everybody on television, local television, would be like, hey, make sure you protect your windows, put up plywood, put up shutter, put up something like that. But if you don't have anything, if by chance one of your windows break, they tell you to go on the opposite side of the house and open up that window. Tell me why you think that happens. Yes. Absolutely. If not, it's going to be the balloon effect, right? You have one window that's broken on one side, and then just air starts to come in, and it's just like a balloon. And that's what when your roof starts to go. That's why you have so much roof damage during a hurricane as well. Because there's a lot of wind that's coming in, a lot of pressure that's coming in on one side. And so those are some of the safety effects. With us, of course, being in the glass industry, one of the things that we have is impact-resistant glass. So in your cars right now, it's the front of your car, it's the windshield. So if by chance, like everybody's seen movies where like, there's a crash and somebody goes straight out that front of the window, it doesn't happen. Because there's laminated glass there. There's two pieces of glass, kind of like with a plastic piece in between. It's like a sandwich, and it keeps things intact. And so the sides of your windows are able to blow up like that. But this is hurricane impact, to where you have some kind of like impact on it, and it can break. Glass is supposed to break. However, it's not supposed to vacate the entire opening. So in a hurricane, it can break, but it's not going to open up like this here and cause all of the damage. Man,
I know. There were such good pictures.
so there's a photo I really want them to see. Is this one with the kid?
It's the kid, yeah.
Okay, we gotta show that photo.
Yeah,
So this here is an actual home in Florida, to where there was so much of the flooding from the hurricane that came in and brought a lot of the sand from the beach. So pretty much that house there was, oh good, hopefully maybe that'll be a good way of doing it.
Probably not.
I don't know, but this is somebody's home. See like the windows there? I mean, like, so all the sand actually like filled up the ground floor of all of that.
I'm just going to pull it up on my laptop.
There you go. So anyway, so what we're trying to show is that the damage that can happen, but there's homes in, in Latin America, and like Haiti. These are places that have a lot of, they're used to hurricanes. They're used to this type of like weather events. I'm from South America in Guyana, and there's a couple photos there that I'll show you. Our homes are built on stilts.
Yeah, yours got deleted.
It's there, I promise. But it shows that the homes are actually built on stilts. This is just the everyday way of building, to where you know it's going to happen, and you don't have to pay every year to go get it fixed or have water damage or anything like that. You just got to make sure that you build a certain way and a proper way of doing so. I hope it works. There's a photo of this like kid attempting to go into his home, and well, thank you. What is that? Okay.
Perhaps not.
Is there a HDMI at all?
Yeah, I plugged it in. I just don't know if it's
Is
going
that
to
on it?
Yeah, maybe I also have to plug this in.
Do y'all know how to do it?
Who's smart?
I know. I heard that sound. Usually that's the sound that comes with the
I
HDMI,
know.
right?
It knows it's in there.
You know how to do it?
Whoop.
Ah, nice.
Whoa,
We're losing stuff.
All this needs is just to be pulled out and plugged back in.
Oh yeah?
And I don't plug in that conference thing. No, it has to.
Do we lose it all?
No.
I think they're trying
Why
to
is
switch
the
to
black-
their laptop.
Yeah.
No, we're losing a lot of them.
Yeah, it corrupted.
Oh, it's not. I thought it was on the screen. It's just on
No,
the...
it's in the actual presentation. So I was
So,
going to switch to my laptop.
Okay. Well,
Is that possible?
You need this HDMI.
this one.
Thank you.
You're welcome.
Sorry, this is not my strength.
No, that's fine. You might have to mess around with some display settings. I don't know.
That's
Oh, there we
okay. Okay.
Would you have to hit the enable content again?
It's not videos, so it should be fine. But this is why we're like civil engineers.
See, I wanted you to see this. This is the photo I wanted you to see, because this is your home. This is the actual door itself. This is your single hung window. So pretty much when you walk into your home and you're opening up a window, you're not opening it all the way up from here. You're just like this. So that's how much sand is in this home. That's how much came up on here. This guy's trying to get into his home this way. That's how much washed up.
It's like at doorknob height.
Yeah, so that's how much like washed in from the beach. That's what's happening up here as well. So this is some of the effects of a hurricane. So it's not just and the wind-driven rain and the impacts and things like that flying around, it's also all of this happening here. And then of course you have all of the water damage that comes in as well. So you see some homes here. I think there's some cars that are underwater. Think about a typical car. Usually, you know, I'm like right here in a car, depending on which car it is, what model. Usually they're getting higher, but they're underwater. So that's much water right now that will come through during a hurricane. Yeah, see some of the buildings. These are apartment buildings. This looks like some kind of commercial building. This looks like some kind of hangar.
And this is Asheville, so this wasn't even hurricane storm, it was just the flash flooding from the increased level of rain.
Exactly.
Yeah, so one of the side effects of hurricanes, floods, so like that's something that people who design buildings need to think about as well. There's some low-tech solutions, big fans.
Yes.
Irma, I forgot to put your house in here.
Oh, that's
Sorry.
fine. They had my home from when I grew up in South America that they actually had. It was the entire bottom of the home was on the columns. So just the entire home is built on stilts. And the island that I grew up on, it flooded every single year, sometimes twice a year. And so people on the island knew you got to build this way. If not, you're going to lose a lot of stuff all the time. And so that's just the way to build. And so I think in Florida, one of the code changes that we'll probably see in the next edition of the codes is that they're going to start building this way. Because insurance is not going to pay to get all that sand out of the homes. How do you go back to living in that home afterwards? What about the mold inside of the homes? What happened with all of that water? There's a lot of damage, a lot of stuff going on there. So I think this is something in which at least we're trying to get to change to where homes need to start building knowing what the climate is, what's going to be happening. This is also a public building in South America, in Guyana. You see, this is actual business, to where it's built knowing that there will be some flooding. It's minimal, vegetation around, but they already know that. So building that way is always, preventing the big effects of things. This is a water tank. We capture the rainwater from the roof that goes in here, piping, and so that's how they get it. If you want a hot shower, you take a shower when the sun is up. If not, it's going to be a cold shower.
And then, so this is some of what I used to do as a water resource engineer. We would build hydraulic models for cities when a land developer wants to build a neighborhood. So now he needs a hydraulic model to see which areas of that are going to flood, because inevitably the rain will come, and we have all this data on like storms and what does that look like for us. So we would design at my company for 100-year storms, which are pretty rare but becoming quite common. Despite the name. So a lot of the things we would do is just make sure that we're reducing development in river corridors or on floodplains that are going to raise up real quick when it starts to rain because they're so saturated. And that's just the way the land wants to move. It wants to be full of water. So if you don't want your home to also be full of water, you don't build it there. So then reduced impervious surface areas like concrete. Like a building, concrete, sidewalks, roads, all of that is impervious. Water has to go somewhere. It's not going down, so it has to go out. So some of the things we do to reduce impervious surface area is you preserve your wetlands. You can restore your wetlands. That is a huge thing that like some cities are looking into, to restore their wetlands so that they stop flooding. It also helps like filter the water that's going into the ground. So native plants are huge for that, wetland preservation, conservation, all the good stuff.
How many of you know where Oak Point Park is? It's where the Balloon Festival is. That's part of the storm drainage. Did you know that? So whenever it's during when it's like the high rain time, sometimes you see that area flooded. And then near Kroger on 15th and Los Rios, there's a golf course. Plano used to have that as their golf course. Lots of homes around the golf course. They decided to put that as part of their, just a park now, because they used to flood so many times. So that's part of the whole building with this in mind as well.
Mm-hmm. You build with nature. Like those areas are supposed to flood. They want to. We don't want them to, but that's just too bad. And it acts as like a wetland axis, and native plants act as like natural water filters. And so when you get rain and chemical runoff and all this nasty stuff that comes down from the roads, asphalt, plastic, anything, it all goes into the wetland, gets kind of filtered by the plants, then makes its way out to the sea. And so that's just a great way to keep our earth happy. Another like higher tech solutions could be these flood prevention barriers. They're more expensive. It's kind of it happens typically in like older cities. This is one in Europe. I think it's in Scotland. So they have this impact resistant glazing on like steel framing. And so it's kind of a dam, but you can like see how high the water gets during rain. But that's just like, that's an old city wall. It's preserved. You have to do something. And so they chose to just build on top of it. My personal favorite is pervious pavement, or adding pervious surfaces, and if you can't add wetlands or grass or plants or whatever, you need the pavement, add pervious pavement. It's a really cool technology. It's a little more expensive than regular pavement, but it's like this natural filter. You filter through stone and mineral down, and then you have this drain, and it drains out to your stormwater system. So it's a great way to like have a city that isn't really messing with the flow of water. I told you I did it.
So one of the things about hurricanes as well is the damage of tornadoes. They spawn just like down spurts of the air, and so I asked her to put like frogs in there, like a shark and things like that. I like with the cows there as well. So, but there are homes in Oklahoma. There's a FEMA standard, a federal standard that talks about how to build with tornado in mind. And so this was many years ago, somebody asked, they want to build with glass for a tornado impact or tornado resistant home. I was like, why would you want to see it coming, And so, but they actually they are pieces of glass in which you can build with, and you can have a tornado resistance home. There are some of them in Oklahoma right now, so.
Yeah. Yeah, these are my least favorite, so I didn't want to put a real picture, so I put a cartoon. So it's not as scary. But yeah, this is one of the things you can see coming, so it's one of the things that's like, it's easier to be prepared for it. This is my dream home. It's a mock-up for this like idea of a tornado-resistant home. So this house, at the top it has, this impact-resistant glass, super cool, you can have all this daylight. It's supposed to be like self-sufficient, so it like makes its own oxygen, energy, waste, everything. But when the sensors on the walls like feel high-speed wind, it drops into the ground. So it is tornado-proof.
I love it. It's like telescoping, right?
Yeah, and then it's made as like a shape that doesn't catch the wind, so it's this flat kind of roof, nothing to like lift up. But yeah, that's my dream home. This is you.
Yep. So I said I used to work for a laboratory in South Florida. This is how we do some of the testing. And I've given a presentation, I think maybe 2 years ago, where I actually showed some of the actual testing in a car and for hurricane as well as tornado. But it shows, this is a 2x4, which is a regular 2x4 that you guys have in the fab shop right now. And so they wanted to know what actually comes about in a hurricane. How can they replicate flying debris? And so they have two types. There's a small missile, which is just BBs, and then there's steel ball bearings, and then what replicates like roofs that have concrete on them, and pebbles from the sidewalks, and mulch and all that then comes up from from there, and in a hurricane or a tornado, and then now has that momentum and acceleration that hits your building and causes that opening. And so your glass, and not just your glass, I've tested roofs, I've tested walls, I've tested shutters, different things like that, to where there's a standard. And so testing all of the different building materials to the same standard allows like equality where it comes to the different building products. So you can build a home with all glass building and have this. Or you can have your walls, your roofs, your everything else that actually have this as well. And so the standards are there. This is something that's, Florida has their codes, their actual code itself. Remember when I said it's the worst building that you could possibly legally build? In their code they have that you have to use this type of glass in your system when you're building a home, an apartment complex, Miami like beach, like the railings, for example, like a nice condo, those are all impact resistant, and because of this reason. Texas Building Code on the coastal areas, Galveston area, Rockport. Those are some of the areas that have some of these codes that have the higher levels as well. And then now we're looking at the international codes to where it's like, okay, now up in North Carolina, sometimes every once in a while we have one, hurricane that goes all the way up to like the East Coast. So sometimes it goes to New York City or Maine and things like that. So those are some areas you don't have it as often, but they're also looking at changing the codes so that way they don't have to cost so much.
Yeah, so overall, building resiliency is like kind of the theme of this. I think it's like the theme of, building in the future. Structural reinforcements, like how critical that is for storms, for wind resistance, for fire resistance, flood resilience, fire resistant design, energy resilience and sustainability, making sure that you're not actually like contributing to the climate crisis by responding to the climate crisis, and then building codes compliance. And like being involved in building codes is super important for engineers, for architects, for any sort of contractor. It's super important. That's why Irmela does it for our company. She makes sure that like our industry is being represented in the codes meetings, because otherwise like no one's going to do it for you. So it is really important. If you're like really passionate about, hey, this needs to get done, like just do it, or send her to do it.
Drag you along.
Yeah. Any questions?
Are there any plans or any technology that is currently being thought of that could be implemented in buildings that already exist?
Yeah, like retrofit?
Yeah, definitely. It's called retrofit. So like my home, for example, I totally ashamed to say that my home was built in 1999. My windows 2 weeks ago, when it was like so cold outside, there was ice on my frames. I know better. I should have better windows. However, they cost the money, right? And so where it comes to that, so one of the things I'm doing this year is actually getting new windows put in that has not the metal aluminum framing, but a different type. But in like this building right here, absolutely, you can change out your windows. So the majority of our homes and our buildings are 2 pieces of glass. If you go truly up to it and look at the glass itself, you'll see a metal spacer in between, so that actually keeps the heat and the cold out and gives you a little bit of a buffer, like a thermal buffer on the inside. And so, but there's a lot of buildings. I think it was 50% from the Department of Energy, 50% of our buildings were built with just 1 piece of glass. And so the part that we can change on retrofit to help with all of this is to now put in a newer type of glass, newer technology. They have it to where they're thin. They have 3, like your phone, you know how thin that glass is? They have 3 pieces of that in it. So it's called a triple insulating glass unit, to where you can now take that unit and put it into your existing frame. So you don't have to mess around with a full, complete, like retrofit or like framing and everything else. It costs money. There's a vacuum insulating glass as well, to where it's 2 pieces of glass and the vacuum pulled out all of the air, so there's nothing there. There's no heat transfer there. There's no sound transfer in all of that, just around the framing area. So there's lots of materials that's on the market for retrofit, and that's one of the things that people start to look at when, instead of building a new building, can we reuse that? Especially right now with the energy crisis and where it comes to climate and efficiency and sustainability and all of like your green words that are out there right now. They're like, hey, how can we repurpose this? Like this building that you're in was an office building, and they repurposed it for the school. So it's like, how do we repurpose buildings instead of just building a brand new one again? In Japan and I think in Europe, when they build a building, they build the entire building for at least 50 years to 100 years. Whereas in the US, when we build a building, we put it up really fast, and each floor, especially in retail, each floor, it's kind of like, okay, that client's gonna come in and they're gonna do whatever they wanna do. So they can fix it. So we don't actually build the buildings to where it's going to withstand years. We build it to the consumer who's going to come in, or the client who's now going to come in and make it their space. So that's one of the differences in the US versus elsewhere.
So would you say it would like continuing to be more efficient to like reuse old buildings with the growing overpopulation problem?
Population problem when we're using buildings. So one of the things that COVID, like you know how we're all home during COVID, and then the school was just kind of empty, and lots of business was just empty. A lot of people stayed home to work. And I mean, I've always worked from home since 2007, but there are many people now who are like, hey, I was actually able to work more productive from home. So what do you now do with all of these downtown buildings? So one of the things that they've talked about, even in Dallas here, they've talked about, can we repurpose the commercial buildings? Because you already have bathrooms in them, but you have a multiple areas. Can we do all of that for homes now? Can you now start to repurpose that? You have restaurants already in the business district, so you already have a little bit of a foundation there. How do we now use some of those old buildings? There's now a movement to where like, hey, people need to go back into the office, but a lot of people are like, I can work from wherever I want, you know, and can do so at any time. And so I think that there will be a movement to where you can repurpose some of these commercial buildings for housing.
I think to add on to what you said, it's already been done because I remember seeing a video of a company, they repurposed a commercial mall, you know, for housing, right? And it's also like a tiny community in there. A question I do have is, can you go to the slide with the kid trying to get into his house in the sand?
See, aren't you glad that we made sure this on that program?
All right, so like on the top right picture, you know, with the bent down tree and the house there, on the left of that window, there's like this big open hole. I guess it looks like there was supposed to be like a garage door or something.
It could have been a garage door that got blown out. Yeah. One of the things when I was working at the test laboratory, that was something we impacted. We impacted the garage door, and living in Florida and having a garage door, you actually would butt up your car right up against your garage door. So that way it would not come in and out with that negative and positive pressure from the earth. So you actually put your car up against that to kind of help. And then sometimes on the garage doors, they have kind of like, just like a bar that comes down. So in preparation for that as well. So yeah, it looked like probably the garage door got pulled out. Yes.
So like in more of the modern buildings, especially like when you see them, most of them are just built like completely out of glass. So like, especially
My favorite type.
Yeah, especially when you see the pictures. So like, does that pose a huge safety concern?
That's a great question, because that's what I thought before I met Irma. Because I'm an environmental and ecological engineer by like education, and so I'm like basically just like a professional tree hugger. And so I was like, oh, but glass, like that's not good, because like it's not very energy efficient. It can't be, because like that's just cooking the people inside. It has to be, but that's just bad glass apparently.
There's a photo. I think it's one of the fire ones that.
Oh yeah.
Like it's an all glass, right here.
Yeah.
See right here? See, they have like glass railings so they can have the view of the, you know, of the sea, I guess, or the ocean. And then you have a whole bunch of different things there. So I have a presentation. I have it, there's a glass for that. And so if you can think about it, we have a product for it. It's just how much are you willing to pay for it. So glass, could you go back to the Venn diagram? No, I'm actually bringing a lot. So right here, so this is one of the things. So here's your commercial building, here's your home. So the glass security is one of it. So right now, we have a code proposal to where we're going to change legislation as well as building codes to have school security. So where we actually have the secure of a building itself on an active shooter, but it also force entry resistance. So sometimes you have vandals who are like, hey, let's go ahead and just kind of like, you know, hang out on a Friday night or whatever, just for pranks or something. So there's like force entry resistant. There's security, there's hurricane, there's energy efficiency we talked about, flooding, bird friendly. There's a lot of stuff about birds flying into windows these days. And so there's actually like a coating on the glass that you and I can't see, but the birds can see, to where they avoid the glass. There's turtle friendly. So what do you think what happens with turtles? Yes.
So turtles, I'm assuming you mean when they hatch.
Yes.
They tend to go towards the moonlight, but now with big problem is light pollution, they no longer go towards the moonlight, they go towards all of our light.
Yes,
And
the house lights.
then
Yeah, so now they're going up.
bad things.
Exactly, instead of going out to water to sea turtles. So marine life, so it's, instead of going on the moonlight, there's a hatching cycle, so they go towards the moonlight, which is the sea that they need to get into, or the water they need to get into. They see the homes, the lights from the homes. So in Florida areas and anywhere area that has sea turtles, they have a lights out program at nighttime. Or they have a coating on that glass to where you can use your home, it's just the turtles can't see it. So that's what this is. But yeah, we have fire acoustics views. Do you know that by having access to daylighting, you in this room right now, it's the difference between a C student and an A student? Yeah, just because you have access. Because you know what's going on outside. And so it has to do with our bodies and the way that we view what's going on. And in hospitals, that's why you have so much glass and windows also in hospitals, because you can heal faster. Insurance companies are on that because it's like a day and a half. You can actually heal faster because of that. And daylighting, of course, recyclable and reusable. So one of the things that Georgia, she is incredibly passionate about it, is reusing the glass. She actually has a map that she created to where it's like all of the places that have the retrofit buildings, you're now taking out this glass. What do we do with this? Instead of landfill, then you can use it so many other places. You know, can reuse the exact glass itself depending on how it comes out. But then there's also other different things that you can have there. And then of course decorative and then safety as well. So to answer your question in a very, very long way, you can build an entire glass home and still be able to do this. So yes, it is secure.
How is impact resistant glass built differently compared to just regular glass?
Want to take down?
No, that's like your thing. I've never tried that.
So glass itself comes off of a bath. It's kind of like a tin bath, and they have the sand, and they have the silica and everything else. It goes up and melts really, really fast, and then it comes off of a ribbon. So that glass itself is called plate glass. It's called annealed glass. So that is easily breakable. So then they go into this, what is it called? What type of process is it? The annealed glass goes into a what process?
To a float plant,
To make it stronger?
quenching.
Yes. So it goes into a tempering process. It goes into an oven. Kind of like you shove, you bake cookies in the oven, right? So you go putting cookies, it's really, really soft, and then all of a sudden it starts to bake and it hardens. So that's what happens with glass. So after they get the glass, the raw glass, then you're gonna try to get it. Nice. Hey, look at that. So this is how glass is made. You have the glass melting there, you get the liquid tin, the glass, actually all of the stuff that goes into batch, and then the top part, it just floats on top. So that's what makes it flat. So just flat, and it floats all the way here. It comes out here after it's cooled, so it's now you can be able to touch it. And so then you inspect it, make sure that there's nothing that came out of that bath that now has attached to it, and then you cut it and you pack it. Then the next part of it, to make it stronger, is a tempering process. So I don't know if you have that.
I think I do.
So the tempering process is where you now take the glass, you cut the glass for this size here that you want that window. And so now you put that in an oven, a tempering oven. And so what happens is that tempering oven gets it to where it's almost molten. So it's almost kind of like, taffy. And so as soon as it gets to that point, then they quench it really fast with cool air. So by doing so, it now have it to where it has a compression layer and a tensile layer. And so that being said, she's showing one of our top secret things that we're working on right now.
Yeah, don't tell anyone.
We're working on a course for college students. So because I came out with a master's in civil engineering, knowing how to build a building from ground up and everything else, but didn't do anything about glass. And so we're actually working on a course right now. But anyway, so the heat treatment process, now what happens is that you quench it so fast that you have a layer of,
I have this
the
picture.
compression layer, and then you also have a tensile layer. So one thing about glass, in compression, it's stronger than steel. So that's the strength of glass. It's stronger than steel in compression. However, it is a brittle material. So you start to pull at it, or touch it and poke at it, it will break. Glass is brittle, it's supposed to break. And so that's how they get it stronger. The thickness is also stronger. But then there's also layers. So you can have a layer of glass, an inner layer, which is a plastic piece, like what's inside of your car, on the front end of your car, kind of like peanut butter jelly sandwich. You got your glass, which is like your bread, and then you put the plastic inner layer there, and then the other piece of bread, or the other piece of glass, and then you put it into an oven. And then you melt it together, and it has laminated glass. So that's how you get bullet-resistant glass, that's how you get hurricane impact glass, tornado-resistant glass. Yes?
What would you do for earthquakes?
Well, a tsunami, I hope that you're on mountains somewhere. So, because, you know. For earthquake, the way that you build is that the columns itself. So like, you know how here in Texas, you know, you find that like, you dig deep and then you put like is it pile foundation? Mm-hmm. Pile foundation, so it's like you got these columns that go straight down, but then in a seismic area, you actually have it it's not as stable. It's enough for gravity, however, it kind of use during an earthquake, the whole entire building moves, so the columns are moving. They have a seismic glass to where you can actually do like a racking test to where the glass moves inside of the frame. And so instead of it being like silicone, like really, really hard silicone into the frame itself, it's flexible. It's kind of like, I don't know, like gasket material, to where it kind of looks like a Z, a little bit like that, to where it allows movement in those types of glass.
And it sounds kind of counterintuitive, but like you want the give. It's like when you see those videos of like the bridges when they're like swaying and you're like, that looks really problematic, but they're like supposed to do that because the more you disperse the energy, the less likely it is to like crack and like break the building or break the bridge.
Yes?
How have you seen climate change impact your job?
She hired me.
I did hire her because of this.
Yeah. I think it's definitely, I mean, I've not been around that long, but like from what I've heard from like where the industry was like 10 years ago versus where it is now, people, whether they like it or not, have to pay attention to sustainability. Like there's some requirements now, sure, but like there's also like elective things that people can do. Like they don't have to do them. Like documentation you can keep and your data and stuff like that. You don't have to do all these things. You don't have to recycle glass. But like it's great if you do, and soon people are probably going to start requiring that you do certain things. So like watching the glass industry step up to like what they see the requirements will be in the future is like, I think that's pretty unique to this industry. Because like I've been in other ones and they're not as like flexible, I feel like. Like a lot of industries, yeah, they're pretty set in their ways and they want to like, you know, they want to, I mean, just do what works. And like, I feel like the glass industry is pretty like, I don't know, pretty innovative.
I think so. And what happens in Europe, what happens in California, always comes to the rest of the U.S. Mm-hmm. And so Europe have a lot of higher standards. The reason being is that gas is so expensive there. So they can't, like, you know how right now we can fill up my tank with gas for like 40 bucks or something. You know, it's like $2 or $3 a gallon. Over there, it's so much more. And so we have an abundance of it, they don't. And so because of that, there's a lot of, we need to recycle, we need to reuse, we need to build with sustainability. And so what has happened, especially when COVID happened, and President Biden had the Inflation Reduction Act, to where he knew there was going to be an inflation, so we put a lot of this in a bill, trillions of dollars, and an infrastructure, because there were bridges that need to be updated. So as the country was shut down, they're like, hey, what can we focus people on and build in the meantime, where we're not having a lot of like, you know, shipping and exports with the different countries and all of that. And so there were a couple of bills that were passed there that influences a lot of infrastructure because of that. And so, I think because of that, there's a lot more internal to where, you know, companies and even building owners and homeowners are now starting to look at what's going to, you know, when things get bad again, when things get more expensive, how do we save? And so a lot more sustainability is coming this way. With President Trump's administration, It's more of that on a national level, not necessarily wanting to do it that way, like, pulled out of the Paris climate change, what is it, Paris?
Climate agreement.
The climate agreement. However, what we're now seeing is that the states are picking up some of that. So at the state level, you have California doing certain things, New York doing certain things, Washington State doing certain things. So things are still going to go sustainable, depending on whether it's at the federal level or at the state level. But usually Europe and California are the ones that, that are, we look at anyway. So we see that start happening and we know it's coming. But this is how, yes, so it impacts us a lot.
So what does
Different foundations.
Yeah, people choose different like materials for foundations depending on like where you live. So like depending on like the soil type, if it's gonna be too rigid. I mean, our foundations like shift over time in Texas because we expect a certain amount of soil shift. And when I lived in Indiana, it was different. Like they don't build like that. Their soil's a lot like more sturdy, for lack of a better word. And so like they build like more rigid foundations. So I don't know if that answers your question. I don't really know the details of like the materials used. I mean, there's different like compositions of concrete and like steel rebar and things like that that they make foundations out of, and like where you would put it. Do you put it further down? Do you put it higher up? But yeah, I don't really know like the composition that changes.
One of the things that I like, like New York City, Manhattan, for example, it's like one of those things. It's like however many stories you need to go up because they've built so much on that piece of island there. It's like in order for them to build up, they have to build down as well to like get to like bedrock. And so that's one of the differences as well, depending on where you are in the U.S. and the regions, how you build.
So you may have more questions, but I'm sure you will see at
Yeah.
Ms.Neeta around
Yes.
around school.
I will make
And
sure.
maybe even Georgia.
Oh, absolutely. Make sure Georgia's
So,
involved too.
big round of applause for these two.